Good morning. I'm going to talk a little bit about open source, which is, of course, the theme today, and in particular talk about how it's related to interoperability. And so to jump right into the story, really the first time people started to talk about and hear about open source in networking was back around 2011, when some of the world's biggest web operators found that they couldn't make changes in their networks fast enough. And there was a particular story of a particular big operator who investigated the problem in their network, figured out what the solution was, took it to their big vendor and said, we'd like this solution so that we can operate our network. And even though they were a huge customer and huge revenue for the operator, the answer came back, our product management people have looked at your change and we can get it into a release in about 15 months. And so I think that was at the point where that operator said, we're going to go build our own switches and we're going to take the open source projects and make them good enough that we can deploy them in our network. And so around that 2011, what we used to call the big five in North America, Microsoft, Amazon, Google, Facebook, Yahoo, all sort of started doing this, building their own network equipment using open source software. And around that time, the rest of us in the industry started suggesting that everybody else should be able to participate in this as well. It's a little more complicated for smaller operators, obviously, than for the bigger ones, but I would say a lot of the progress we've made since 2011 is really getting to the point where everybody can participate in this, not just the world's biggest giants. And so as we come into 2016, it turns out there are tons of open source infrastructure projects. Software-defined something or other, storage or compute or networking or other things, but if you just look at all these logos and tags, everyone's doing it. And I would claim that a lot of people, the reason they're doing it is because everyone's doing it. And I would claim that a lot of people's understanding of why we're doing this is because everyone's doing it. There's actually some really good fundamental reasons, besides everyone's doing it, that are driving this, and I want to talk a little bit about that. So I think from a vendor perspective, certainly open development is a shared investment. So here's an example, a little spreadsheet I threw together. And so both the closed ecosystem approach and the open ecosystem approach, I chose for this example to say there's 1,500 developers. So the question is, how do you allocate them? In the open source environment, you end up with one controller that's shared by everybody. In the closed source environment, you end up with 10 controllers that are each driven by a different proprietary group. You can see in that case, the one controller that the open source people builds ends up with 5 times as many developers and engineers committed to it, so they have a lot more resources and opportunity to make it strong. If you look at the number of applications, I'll call them, it's probably not the best term, but things that sit on top of the SDN controller and do useful service-like things. In this particular case, if you said there were 5 developers per service, you end up with 110 of these services in the open ecosystem, and you only end up with 10 of them in the closed ecosystem. So really just simple arithmetic. If you agree that the basic platform has some pretty well understood functionality, it just doesn't make any sense for everyone to develop their own. We could all develop one together, and then we can all invest lots of our resources in building value-added things that live on top of this. Another reason why everybody's going open is because really it's the new way to get to interoperability. Traditionally, standards development organizations and standards were the source of interoperability. And that tended to follow a design pattern that looked a lot like the waterfall pattern. We'd spend years thinking about every corner case and use case in the universe, and then try to draw some piece of paper that's going to support all of them. Open source development, on the other hand, is much more of an agile process. You build a little bit of something, you see if it works, you find out what worked and what didn't, and you iterate. And so, really Dan and other speakers this morning talked about, what we're doing as an industry is really a giant real-time experiment. The old waterfall model based entirely on standards development, again, is just too slow and not agile enough for what people need. But at the same time, we do need some of the formality and discipline that came from the standards organizations. So as an industry, we're kind of doing this giant experiment of trying to figure out how do we balance open source and standards development and get them to work together. There are several different approaches being taken in the industry, and we have yet to find out, who's the winner. Finally, the power of community, and every other speaker has talked about this, but if you just look at these things as ecosystems, do you want to, if you're a vendor, do you want to sell into the giant green ecosystem or one of the tiny blue ecosystems? Easy choice. If you're an operator and you have a problem in your network and you can't solve it, do you want to reach out to the giant green ecosystem and say, has anyone ever seen this problem before? Can someone help me solve it? Or do you want to reach out to one of these little tiny ecosystems and hope that somebody there has seen your problem? Or worse, do you want somebody to say, hey, I have the same problem as you, here's the solution. You spend a couple of weeks messing around with the solution, and then you find out, oh, sorry, I was using a different version of the platform or a different fork. And so really, every time you fork an open source project, you divide the size of the community in half, you divide the number of available experts in half, you dilute the focus of the market in half, you make the size of the market half as big. And so, ecosystems and platforms are driven by network effects. You don't end up with a lot of little ones. One of them, two of them, some small number become really, really successful because they achieve a sort of critical mass where you can't afford not to be part of the ecosystem. The more people join the ecosystem, the more draw there is for other people, and eventually, these big ecosystems pull everyone in because you can't afford not to be part of it because of these many advantages of community. And so where we're getting to, as an industry, is an open source IT stack. We're building a completely new stack based on these new ideas, orchestrators and controllers and things that weren't here years ago. Really, what's new in all of this is end-to-end. If you think about SDN controllers, what are they doing? They're kind of going from a device model to an end-to-end model within an administrative domain. If you go upstream a little bit and you look at the orchestrators, what are they doing? Well, they're building end-to-end across administrative domains and across different controller types. But really, this is the piece that was missing. We had a distributed systems approach to all of these things, which said that you can't think about the whole, you have to just think about each of the piece parts. We've now come full circle and realized that the only way to scale and to manage things at this scale is to think about the entirety of the thing and use smart technology to partition the problem into smaller problems that we can solve. So this happens to be the OpenO, or one of the OpenO pictures, and I just borrowed that to represent that essentially all across the ecosystem and all up and down the stack, open source projects are creating the new building blocks, and really, as an industry, what we're doing is integrating all of this new open stuff. And so, another trend that's happened alongside of this is we've changed the way we think about SDN controllers. And in the first generation, the thing that was called an SDN controller, I would argue, was an OpenFlow multiplexer. You pushed OpenFlow in the top, and it distributed to the switches. Didn't really do anything. Now we've moved, and so everything that was intelligent or did anything useful somehow lived outside of the controller, and we called it an application. There was tons of redundancy, no reuse of functionality, and people who developed applications had to be experts both in their application domain and in all of the network technologies. So we moved more to a model where we have a thicker controller. I'm sorry, I just realized I labeled these, left and right are labeled wrong. So left was the first generation with the fat applications and the thin controllers, and right is the second generation with the fat controller and the thin applications. But if you can recall the diagram that Colin showed for Open Daylight, or the diagrams you've seen for OpenO, diagram I'll show in a ONOS talk tomorrow, they all follow this fat controller module. There's lots and lots and lots of powerful functionality that's been built as part of the controller and is available as a library to developers, so that you don't have to understand all of the inner workings and all of the interfaces with the southbound. You just have to understand the interfaces. And so one other comment along these lines is, as Colin mentioned, we're really trying to make up 40 plus years of innovation and open source across the industry that somehow the networking business got left behind on. The problem is there's a tendency to ignore the fact that it took us 40 years to get there the first time, and now people think we're going to do it in 12 months, 18 months. You know, what all the operators want is they want the closed source solutions that they're deploying today, and they want them to be open source so they can feel good about it. You can't have both. As I've said a lot recently, the deployable solutions aren't open enough, and the open solutions aren't deployable enough. It's going to take a while to get there. You know, these little baby projects that are born in the Linux Foundation in the last 2, 3, 4 years can't suddenly become mature and deployable for everybody, for everything, overnight. And so we've got to remember that we're getting there, we're making amazing progress, but it takes some time, and no matter how badly we want all of our solutions to be open overnight, it's simply not possible. So really the reason we built many, many standards organizations, the ITU, the IETF, the IEEE, ETSI, you name it. This was the only way we could get multiple vendors to build things together that could actually interoperate on some level. And so now we've talked about how that's not fast enough, that's not agile enough. We need a faster way to get to interoperability. And the question then becomes, how do we do this? And I'm going to talk specifically about SDN controllers. And so if you ask the question, well, can't we solve this by having a single common southbound, maybe open flow? What if everybody uses that? Well, it's way too late. We've already got lots of southbound protocols, and none of them are going away. Open flow is one of them, and it's widely deployed, but there are going to be others. And it's not a good goal to have only one way of doing anything. It produces a monoculture, it reduces innovation, it reduces choice, and you know, there's a reason why we have iOS and Android. There's a reason why we have Windows and Linux. Exactly one of anything, if it's an important ecosystem, isn't going to get us there because there aren't enough competitive effects and there aren't enough incentives to innovate. If you say, and Dan described this, the controller wars. Well, what if we all had the same controller architecture? Wouldn't that solve everything? Again, it's way too late. There's dozens of controllers. They're not going away. Getting to a single controller architecture, again, has this problem of creating a monoculture, which is not what we want to do. And so really, of the interoperability approaches that seem to be available for SDN, the only one that seems to be viable right now is to find a common northbound interface. And if we can do this, I would argue it's not too late, that we're on the verge of changing all of these northbound interfaces. We haven't really established a well-known northbound interface. We haven't standardized any of these, and none of them have really escaped into the wild. So there's still an opportunity. It's not too late, but it's going to be very soon. If we end up with 5 mainstream northbound interfaces, we're never going to go back, and it's going to be too late to get to that sort of interoperability through common northbound. And again, as we're changing from sort of the old stack to this new thing with orchestrators and SDN controllers and all these new components, it's a perfect time. We've got to change the interface anyway. Let's ride on that and change it to one that's common across all of us. And so in the ONF, where I chair the Northbound Interface Working Group, we looked and we saw that lots and lots of people were building interfaces where they tried to describe what you need from the network in a way that was more implementation independent. And we got all kinds of people from across the industry together, and we asked the question, how can we get to a common northbound interface? And everybody had a really simple answer: use mine. That doesn't get us to a common interface, it gets us right back where we started. And so unfortunately what we realized was none of these projects are going to go away. They're not all going to change the way they built these things. What we need to do is figure out how to build a thin northbound shim that could sit above all of the projects in process and was generalized well enough and extensible enough that we could easily adapt all of these projects to use it. And if we're able to do this, we get to sort of the classic narrow waist interoperability demarc, where below the common northbound interface, you have a whole bunch of different controllers and different things from vendors and legacy adaptation with EMS systems. And you can take any one of those and mix and match with any of the things that live on the north side, including compute controllers and orchestrators and all the things you see labeled there. So that was really the goal of the ONF, is can we design a thin northbound shim that everybody can use, that can bring together this sort of fungibility, pull anything out of the southbound and replace it with something else, it still works. Pull anything out of the northbound and replace it, it still works. And so really, we've had arguments. Well, is intent real? Is it anything specific? Does it exist in nature? Is it just some marketing fluff? And where we finally got to was to say it doesn't exist in nature. It's a function of its requirements. So we said we want to design something that is independent of the implementation. That's the goal, to make it portable. And so the test of whether something is intent or not falls directly out of the definition, which is if any of the things refer to something in the implementation, then that's not intent because it's not going to be implementation independent. And so then people said, okay, yeah, you've oversimplified, you've thrown away all the complicated stuff. We haven't thrown away any of the stuff. We've just said that all those other things are not intent, they're mapping. So mapping can be implementation specific, and when you put the two together, you can build systems. So all we're doing, there's no magic here, we're taking all of the input data that would normally go into a network and we're dividing it into two separate types of data, and you'll see why that's useful. So on the intent side, we have created a virtual world. It's not reality. You don't have to worry about hard problems. You don't have to understand complicated stuff. You get to live in a world where all you do is describe groups of things and relationships between them, and you're done. Because of this, you don't get to specify or touch underlying resources. You don't get to pick a network path. You don't get to pick a network port or a switch. You get to describe what you need to the network, and some smart piece of software is in charge of optimizing those things and making those smart decisions. And one of the important things we're doing with intent, again, to try to stay in this agile model, is we're not trying to solve every use case in the world before we get started. We're building an extensible framework that's incredibly simple, and then we're extending it in order to support use cases, one use case at a time. And so really the difference between the intent-based operating model and the traditional model, in the traditional model, you're really describing the solution. With the CLI, you're creating, OSPF zones and various things that are really drawing a picture of what the network needs to look like. In the intent-based approach, you're describing the problem and drawing a picture of what the workloads need. And then some smart piece of software is in charge of figuring out how to give you what it is that you need from the network. So normally when I give my intent talk, I have a t-shirt, and on the front it says, don't tell me what to do. And on the back it says, tell me what you need. And that's the whole intent story. If you go to your doctor and you tell them to give you an aspirin and they don't have an aspirin, you get no satisfaction, you go home with a headache. If you go to your doctor and you say, make my headache stop, they might give you an aspirin, they might give you some cold water, they might have you take a nap. There are many, many options. You're very likely to end up getting something to help with your headache if you ask for your headache to stop rather than prescribing the solution. In the network world, you would say, to build a little VPN, you might talk about VXLAN tunnels and full meshes and all kinds of networky things when you absolutely don't need to. You need to say, I need logical isolation for these three things so that they can pretend they're on a network, and I really don't care whether you do it with VXLAN or VLANs or MPLS or something else. The thing, the intent, what I'm really trying to do is logical isolation. And one of the really powerful things about this is in the traditional model, 100% of the people using the network need to become experts, the CCIE or the equivalent, before they can get the network to do anything useful. With this model, 99% of the network users are not network experts. They're experts in their workloads and their applications and their services. And 1% of the people are the experts who manage the mapping side of the story so that everything works. So there are plenty of opportunities to learn more about intent-based networking. I speak frequently at shows and conferences about it, and there's lots of things on YouTube if you're interested. Please come and join us in the ONF Project Boulder, where everyone is welcome. It's an open source project, and we'd love more participation. Just want to talk a little bit about what's on the roadmap for this year for intent-based networking. As I said, we're trying to establish this as a common interface. You don't get a common interface by building it in a single SDN project or a single orchestration project. And so, to summarize this list, we're going everywhere in the industry where there's infrastructure work being done and where there's open source work being done, and we're trying to sponsor a project and find developers to build an implementation of this ONF originated northbound interface so that we can get to the point where we have this interoperable world. And really the goal of the intent project, you know, it's what Colin described, it's what the operators have been asking us for decades, which is a level playing field. Get rid of the vendor lock. If my solution is better, I can prove it because it's easy to insert my solution and it's easy to bake off my solution head to head against your solution. Now, in the intent-based world, instead of saying I'm stuck with a particular vendor forever, you say, every time I refresh my solutions, I'm gonna bake off the best solutions, see which ones work best for me and my use cases and my subscribers, and we're gonna go forward based on that. Again, this is a network effect. If the operators ask for this, the vendors will supply it. If the vendors supply it, more operators will ask for it, and ultimately we can go, hyperscale. We can get the network effect and go exponential and build a huge ecosystem that everybody can participate in. Thank you.